U is the same with time. Volume's the same with time. Pressure's the same with time. Entropy is the same with time. Something is constant with time. It's not changing. Okay. That's maybe how I like to. And these were all just like straight line curves on one of the figures for equilibrium. Okay. So another way to think about equilibrium is often I have to wait a really long time to reach it. Okay. If I had an infinite amount of time, how long would it take for everything to reach equilibrium? Not a realistic case. Anytime something is transferring or something's happening, it's usually over a pretty short period, right? So reversibility and equilibrium are kind of tied together here. A reversible system is one that is always near its equilibrium point, okay? And it could run equally in the forward or reverse direction, meaning if I do something, I push the piston down, I could release the piston back up, and all of the work that went into pushing it down is restored to me when I bring it back up. We know that's not real life. Like, we understand that when I push the piston down, first of all, is the piston actually frictionless? No. So I'm going to have losses to things like heat generation from the friction, noise, vibration. Everything is not perfectly reversible and that I get everything I put in back. This is not how it happens. But if I could, we'd call it a reversible system. Okay? And it would be always near equilibrium. And it also then represents the maximum amount of work I could possibly do. Okay? All of the work that I put in to pushing the piston down, all of that went into pushing the piston down. None of it went to some other loss. Okay? In reality, true reversible transitions never happen because they would be infinitely slow. It would mean I move an infinitesimally small amount, wait for equilibrium to come. Move a little bit more, wait for equilibrium to come. Move a little bit more, wait. I'm actually gonna push this piston down in like half a second, quarter of a second, and call it a day, okay? Understanding what the maximum possible work is from a reversible transition is a good reference point to give you an idea of what the actual max you could capture is, okay? And then from there you can talk about what's really going on in nature. It's always less, always, always. But it's important that you know the words reversible or reversibility and equilibrium. You understand those definitions, and those are keywords to look for in problems too, right? Because if the word reversible is there, it changes what you're gonna do.